So hello namaskar to all the doctors and engineers of the near future and chemistry lovers. मैं विजय कुमार सोनी आपका हार्दिक स्वागत करता हूं केमिस्ट्री वाला चैनल पे रिगार्डिंग टू केमिस्ट्री। बात करूं तो पर्टिकुलर आज से पहले दो वीडियोस ऑर्गेनिक केमिस्ट्री क्लास 12 नीट और आईआईटी के लिए अपलोड की जा चुकी है रिगार्डिंग टू हेलोअल्केन एंड हेलोएरिन एज अ फर्स्ट चैप्टर ऑफ द जस्ट ऑर्गेनिक केमिस्ट्री ऑफ द क्लास 12। उसमें पर्टिकुलर डिस्कस किया हमने व्हाट इज द मीनिंग ऑफ हेलोअल्केन एंड हेलोएरिन and just we have discussed about the just types of the haloalkane and haloarine. Now we'll go with the just nomenclature of haloalkane and haloarine. So if we'll go with the just nomenclature of haloalkane and haloarine, this is the nomenclature of haloalkane and haloarine. First of all, we'll go with the system of the nomenclature. There are two types of the system, two systems regarding to nomenclature. Number A is your, you can say, common system. This is the common system. And number B is your, you can say, your IUPAC system. IUPAC system, it is also called as Geneva system. So there are two systems which are used to nomenclate the haloalkane and haloarine. First of all, we'll go with the just common system. This is the common system. And before starting the common system for the different haloalkane and haloarine, I would like to go with the some of the substituents. And what are they? These are the substituents. Suppose you have any of alkane. You have any of alkane, and if you will remove one of the hydrogen from it, then it will removal of N also, and it will addition of YL as a suffix. So this will be as a alkyl. Suppose you have methane CH4 number 1, then after removal of hydrogen it will be bond CH3 and it is known as methyl. This is the methyl. If I remove the just hydrogen from the ethane C2H6, or you can write it CH3 bond CH3, then after removal the hydrogen, it will be either C2H5 or it will be CH2CH3, known as ethyl. It is known as ethyl. So for the methane and ethane, it will be two substituents as a methyl and ethyl. Now I would like to go with the propane. Propane exists following structure: CH3, CH2 and CH3. So there will be two substituents for the propane. What are they? If I remove the hydrogen from number 1 position, any number 1 position, then it will be CH3, CH2 and CH2 as a N-propyl. This is called as N-propyl, means normal propyl. If I remove the hydrogen from number 2 position, then this will be either as follows: CH3, or you can write it CH3, CHCH3. It is called as isopropyl. Isopropyl. So these are just, we can say, regarding to methane it will be one substituent methyl, regarding to ethane it will be one substituent as ethyl, regarding to propane it will be two substituent as N-propyl and isopropyl. Now I would like to go with the just 4 carbon as a, you can take, for the 4 carbon there may two structures as follows: number 1, and another may be as follows: number 2. Substituents what will be? If I remove the hydrogen from number 1 position, from any position, any number 1 position of the normal structure, then it will be CH3, CH2, CH2 and CH2. This is called as N-butyl, normal butyl. If I just eliminate the hydrogen from any number 2 position, either from left side or right side, then it will be your CH3, CH, this is the CH2 and CH3. It is called as secondary or 2-degree butyl. Secondary or 2-degree butyl. Now I would like to go with the further. Then we can remove any hydrogen from any these 3 conditions. Then it will be as a CH3. This is the CH, CH3 and CH2. This is called as isobutyl. isobutyl. And if I remove the hydrogen from the at the mid, then it will be your CS3, C, this is the CS3 and CS3, and this is the bond field. You can write it by skipping, yeah, by flipping as follows: CS3C, CS3, CS3 bond free. Then it is called as 3-degree butyl or tert butyl. This is the 3-degree butyl or tert butyl. So we can say that what is the important thing? If we'll go with the just the substituents, number of the substituent, then for methane it will be one substituent. One substituent. For ethane again it will be one substituent. For propane it will be two substituent. Remember one thing. For butane it will be four substituents. Four substituents as a N, secondary, iso and 3-degree or tert butyl. So this was about the 4 carbon. We'll discuss about the 5 carbon also. So now we'll go with the 5 carbon also. So we can take over here, and after that we'll take common system for the all halogen derivative, and further IUPAC system. It's too important. So listen me carefully, and we'll take the entire nomenclature in just one video. Either that is long, it doesn't matter, but it should be over one of the position. So if we'll go with the 5 carbon, then this is for the 5 carbon. For the 5 carbon we can take these 3 structure. Number 1 CS2, CS2 and CS3. Number 2 is your CS3. This is the CS3, CHCS3, CS2 and CS3. This will be as a your isopentane also. This is the CS3, CCS3 and CS3. This is called as neopentane. If I remove the hydrogen from number 1 position, then it will be CS3, CS2, CS2 and CS2 and CS3. Sorry, CS2. And over the number 1, either from here or here, then this is called as normal structure, so it will be N-pentyl. N-pentyl. If I remove the number hydrogen from the number 2 position, either from the left here, from the right from here, then this will be as follows: CS3CH, this is the CS2, CS2 and CS3. This is called as secondary active pentyl. Secondary active pentyl. Active means just that is the optically active. उसके साथ कंडीशन ये हो रही है कि उस कार्बन में जितने भी 4 ग्रुप अटैच है A, B, C, D, वो डिफरेंट है. मीन्स A इज नॉट इक्वल टू B, इज नॉट इक्वल टू C, इज नॉट इक्वल टू D. ये वाली कंडीशन फॉलो होगी इसके लिए. So that's why it is called as active. Because of this, carbon is called as active whenever it exists for different group, and it also exists one of the CSD, one of the H, one of the long chain, and another 4th group which will be attached. If I go with the 3rd, then we can remove the hydrogen from the number 3rd position. This will be your CS3, CS2, CH, CS2 and CS3. This is called as just your secondary pentyl. Secondary pentyl कहेंगे इसको, particular number 3 position से confused ना हो. So this was regarding to this first structure as a 3 substituent, as an N-pentyl, secondary active pentyl or secondary pentyl. Now we'll go with the second structure. We'll remove the hydrogen from the number 1 position terminal from the right. Then it will be your CS3, CHCS3. We have discussed this structure is also called as iso, and remaining 2 carbon will be CS2 and CS2. This is called as isopentyl. Isopentyl. If I remove the hydrogen from the number 2 position, then this will be as follows: CS3, CHCS3. This is the CH bond CH3. We can write the structure as follows also by flipping CH. This is the bond CHCS3, and this is the CS3. This is called as secondary, you can say iso secondary active secondary active pentyl group. You can say again there are four different groups will attach over the carbon. That's why this carbon is called as active carbon, and that's why it is called as, and this is the iso structure, and it's a secondary condition. That's why iso secondary active. If I remove the hydrogen from the just here, then the structure will be as follows: CS3. This is the CS2 and CS3. This is the CS3. We can write it by the flipping as follows: CS3. This is the CS3. This is the CS2. This is the CS3. Bond free. This is called as 3-degree pentyl. 3-degree pentyl or third pentyl also. So this was about the, we can say just your 1, 2, 3, 4, 5 and 6 as a substituent. We'll take 2 more substituent also. Read the matter properly. Now we can take just further substituent also. If I substitute the hydrogen from here or here, then structure may be as follows. These are the two important structure. One of the, because we don't have proper space over here. So if I remove the hydrogen from here, then this may be right as follows: CS3. You will go from this side, CS2. This is the CH, CS3, and here will CS2. Then this is called as active pentyl. This is the active pentyl. And if I remove the hydrogen from any position from the third structure, then this will be as follows: CS3, CCS3. This is the CS3 and CS2. This is called as neopentyl. So what we can say that here will 1, 2, 3, 4, 5, 6, 7 and 8 as the substituents for the 5 carbon. So we can write here 8 substituents regarding to 5 carbon. So read the entire matter properly. Now we'll go with the nomenclature. Now the time to discuss about the common system. If this video will be larger, then I will take the IPSC in another video. It doesn't matter because it should be completed properly by you. Otherwise, it will be major problem because of the common system of the haloalkane is similar with the alcohol, ether, ketone and amines also. So it is too important. So first of all, we'll go with the mono haloalkane. This is the number 1. We can take mono haloalkane. If we'll go with the common system, then mono haloalkane are known as alkyl halide, whereas a halogen X, it will be F, then it will be fluoride, for Cl chloride, for Br bromide, for I it will be iodide as a alkyl halide. And alkyl group we have discussed as a methyl, ethyl and propyl, isopropyl, so on. So first of all, I'll go with the first of the compound. This is the CS3Br. Suppose this is the second compound, CS3CS2Cl. You can take FClBri also. This is the CS3. This is your CS2. This is your I. This is your fourth CS3, CHCS3. This is your Br. You can take just fifth compound over here. This is the CS3, CS2 and Cl. This is the sixth compound. You can take CS3CH. This is the F, CS2 and CS3. If you will go with the further seventh compound, you can take over here. This is the CS3. This is your CS3. This is your CS2 and this is the Cl. This is the eighth compound. You can take CS3C, CS3, CS3 and your just you can say you can take I. Ninth compound you can take for the 5 carbon CS2, CS2, CS2. This is the CS2 and I also. You can take for the 10th compound CS3. This is the CHCS3. This is your CS2, CS2. This is the Cl. This is the 10th compound. As a 11th compound, we can take 1, 2, 3, 4, 5, 6, 7, 8, 9 and 10. 11th compound, we can take CS3. This is the CH. This is your, you can take I. This is the CHCS3 and this is the CS3. As a 11th compound, as a 12th compound, we can take CS3, CH2, CH. This is the Br. This is the CH2 and CS3. As a 13th compound, we can take CS3. This is the CS3 and this is the N. This is the iso secondary and iso secondary active. We don't have iso secondary active, so this is the CS3, CH. This is the Cl, CS2 and CS2, CS3. We can take 14 compound as a CS3. This is your iso compound has been taken, so this is the CS3. This is the CS2, CS2 and this is CS3 and this is the I also. This is the 15 compound. This is very important. And what is that? This is the CS3, CH, CS3, CS3 and this is the CS2, 4 and 5 carbon. We can take Cl and this is the 17th compound. All the substituents has been taken. Just your 3 degree has been taken, so it will be neo group. This is the CS2 and this is the Br. If we'll go with the nomenclature, then this is called as methyl, and as I told you, Br is bromide, so the name of compound will be methyl bromide. If I'll go with the next, then it is called as ethyl chloride. Ethyl chloride. This is the N-propyl iodide. This is called as isopropyl iodide. Isopropyl iodide. This is called as N-butyl chloride. N-butyl chloride. This is the secondary butyl fluoride because here is F. This is called as isobutyl chloride. Isobutyl chloride. This is called as 3 degree, you can say, or third butyl iodide. This is for the just 5 carbon, so N-pentyl iodide. This is the isopentyl iodide. Isopentyl, you can say Cl, so chloride. This is, you can say, iso secondary active pentyl. This is the iodide. For this it will be secondary pentyl iodide. This will be your, you can say, secondary active. It was iso secondary active. It is secondary active pentyl chloride. This is the 3 degree or third pentyl chloride. 3 degree or third pentyl. Here is your iso iodide. Here is your iso, you can say, this is the iso. No, we have taken iso. So this is the, you can write as follows. This is the CS3. We can write it CS3 CH2 CH. This is the CS3 and CS2Cl. So we can call it just active pentyl chloride. Active pentyl chloride, and this is called as neopentyl bromide. Neopentyl bromide. So this was regarding to the nomenclature of alkyl halide as a common system. There are the following example. You can practice them properly. You have to distinguish them. Otherwise, it will be very complexity. But it's too easy. Now I would like to go with the just nomenclature common system for the dihaloalkane. That is very important because of many of the students face a lot of problem regarding to the nomenclature of dihalides or dihaloalkane. But you have discussed in 11th standard also, but right now if it is not clear then you can clear it. It's my promise. So this is the dihaloalkane, and regarding to dihaloalkane, we have discussed there are three types of the dihaloalkane. One of the is your Zam dihalide. This is the geminal or Zam dihalide. Second is your vicinal dihalide. Third is your alpha omega dihalide. Alpha omega dihalide. Regarding to Zam dihalide, you can use geminal dihalide, a best word. What is that? You can say alkylidine halide. For the vicinal dihalide, you can use alkylene halide, and for just alpha omega dihalide, you can use polymethylene dihalide. Polymethylene dihalide. Don't be confused. First of all, we'll take the example of Zam dihalide. We have discussed whenever just alkylidine halide, the right pronunciation, alkylidine halide. If we'll go with the just practice of the geminal, then we have discussed that in geminal dihalide both halogen atom will present on the same carbon atom. So we can take the example CS2Br2. This is called as methylidine. This is the bromide, methylidine bromide. We can take another example, CS3. This is the CS, this is the Cl and Cl. Then you can say this is called as ethylidine chloride. This is the ethylidine chloride. If we'll go with the further, then we can take the example CS3C, this is the I and this is the I. You can call it isopropylidine. You can say iodide. So this was regarding to just your Zam dihalide. As a vicinal halide, we can take the example fourth. This is the CS2. This is your Br and Br. It's a very important compound. It is also used as anti-knocking compound in fuels. What is the meaning? We'll discuss later. So this is called as ethylene bromide. Ethylene bromide, because of both halogen atom are present at the just neighboring carbon atom. Regarding to vicinal dihalide, we can take another example, that is the CS3 CH. This is the CS2. This is the Cl and Cl. This will be propylene halide. propylene halide, and if we'll go with the just alpha omega dihalide, then we can take following compounds. First is your CS2, this is the Cl and CS2, CS2. We can take another example, 7th also. This is the CS2, CS2, CS2 and CS2. This is the Br and this is the Br. So you will call it, then what is that? Here is the 3 carbon, so it will be trimethylene, methylene. This is the dichloride. Dichloride is the right word, chloride is the wrong. This is the tetramethylene. This is the bromide. Tetramethylene bromide is the right name. So this was about the common system regarding to dihaloalkane as a geminal, vicinal and alpha omega. Now I would like to go with the just trihaloalkane. Trihaloalkane. This is the nomenclature of common system of trihaloalkane. Haloalkane. If we'll go with the trihaloalkane, then trihaloalkane are known as halo form regarding to common system. These are known as halo form. What is the meaning? If we'll go with the just example, then we can take CHCl3. This is the CHI3. There are the 2 trihaloalkane are as a non-compound. So here is the chloro. So that's why it is called as a halo, chloro and foam. So this is called as chloroform. And if I go with this compound, then this is called as iodoform. So this was about the common system regarding to just haloalkane. So we will meet in the next video with the particular IPSC name of the just haloalkane and कॉमन एंड आईपीसी नेम ऑफ द हेलोअरीन। तब तक के लिए शुक्रिया, धन्यवाद। यूं ही प्यार बांट देते रहिए, यूं ही सपोर्ट करते रहिए। धन्यवाद।